It's repeating a message. Let me be precise about what that sentence means, and specifically about what it cannot honestly mean, because the specific phenomenon it is pointing at is one of the most extraordinary and most genuinely mysterious in contemporary astrophysics. And it does not need the overlay of alien communication to be extraordinary. It is, on its own terms, as strange and as scientifically consequential as any discovery made by radio astronomy since Jansky found the galactic center radio emission in 1932. The phenomenon is fast radio bursts, FRBs. And before I tell you what they are and what the specific repeating signals have revealed, let me be direct about what they are not. They are not alien messages. No confirmed detection of extraterrestrial intelligence has been made. The specific repeating patterns of fast radio bursts are not linguistic, not coded, not structured in any way that resembles deliberate communication. The specific scientists studying them at CHIME, at Parkes, at FAST, at the Very Large Array are not secretly interpreting alien transmissions while publicly attributing the signals to astrophysics. The specific characteristics of the repeating FRBs are consistent with specific natural astrophysical processes and inconsistent with the specific properties you would expect from deliberate communication. Among other things, they arrive from cosmological distances, meaning the signal travel time is billions of years, making any conversational exchange impossible on any time scale relevant to civilization. But here is what fast radio bursts actually are, and why NASA completely baffled is closer to the truth than the alien framing. Not because of alien involvement, but because FRBs represent a genuinely unresolved problem in astrophysics whose complete explanation remains, despite significant recent progress, specifically and honestly uncertain. Fast radio bursts are millisecond duration flashes of radio emission of extraordinary intensity arriving from cosmological distances. They were discovered in 2007 by Duncan Lorimer and his student David Narkevic, who found a single burst in archival data from the Parkes telescope in Australia dating to 2001. The specific burst, now called the Lorimer burst, had properties that immediately distinguished it from any known astrophysical radio source. Its dispersion measure, the specific frequency-dependent arrival time delay produced by free electrons in intergalactic space, was so high that the burst must have originated billions of light years away. But its luminosity, calculated from its distance and its observed brightness, was extraordinary in milliseconds. It released more energy in radio waves than the sun emits in days. In the years following the Lorimer burst publication, the astrophysical community debated whether it was real or an artifact. Then more bursts were found. And then more. By 2024, more than 1,000 fast radio bursts have been cataloged, detected by telescopes across the globe. They arrive from all directions, isotropically distributed across the sky, consistent with a cosmological origin distributed throughout the observable universe. They are frequent. CHIME, the Canadian Hydrogen Intensity Mapping Experiment, detects them at a rate of hundreds per year, and some of them repeat. Let me take you to the specific repeating FRBs, because these are the specific objects at the center of both the scientific excitement and the headline claims. And understanding what makes them scientifically significant requires understanding the specific way repetition changes the astrophysical picture. The first confirmed repeating FRB was FRB 121102, now designated FRB 201211102A, discovered in 2012 at Parkes and confirmed as repeating in 2016 by Laura Spittler and collaborators using the Arecibo telescope. The specific discovery of repetition was significant because it immediately ruled out a specific class of theoretical models. Many early FRB models involved catastrophic, one-time events, the collapse of a massive star, the merger of two compact objects, some specific cataclysm that destroys the source in producing the burst. A repeating source cannot be explained by a one-time catastrophe. Whatever is producing FRB 121102 survives to produce another burst. The specific localization of FRB 121102, determining its precise sky position and its host galaxy, was achieved in 2017 by a collaboration using the Very Large Array. The source is located in a specific dwarf galaxy at a redshift of approximately 0.19, a distance of approximately 3 billion light-years. Within that host galaxy, it is associated with a specific compact region of persistent radio emission, a faint, continuous radio source that co-localizes with the burst source. This persistent source is consistent with a specific young magnetar, an extraordinarily magnetized neutron star embedded in a specific supernova remnant or an active star-forming region. FRB 121102 became the primary laboratory for studying repeating FRBs. It has been observed to produce thousands of individual bursts, a prolific source that allows statistical analysis of burst properties, timing, and spectral characteristics that single burst FRBs cannot provide. The specific properties of FRB 121102's bursts are extraordinary and puzzling. The bursts arrive in specific clusters, periods of hours during which dozens of bursts occur, interspersed with periods of apparent quiescence. The specific burst energies span several orders of magnitude within a single observing session. The burst spectra show specific complex structures, subbursts, frequency drifts, spectral modulations that encode specific information about the emitting region and the propagation environment. And then there is the specific, precise periodicity. Let me tell you about what makes the repeating FRBs most specifically, puzzling the detection of specific periodicity in several of them. In 2020, the CHIME collaboration reported the specific detection of periodic activity in FRB 20180916b, a repeating FRB localized to a specific spiral galaxy at a redshift of approximately 0.03, approximately 500 million light-years away. The specific periodicity, the FRB is active for approximately 4 days and then inactive for approximately 12 days with a specific cycle that repeats with a period of approximately 16.35 days, a 16-3-5-day period, repeating precisely, reproducibly over the specific months of CHIME's monitoring campaign. This is the specific feature that generates the repeating a message framing, and it is the specific feature that requires the most careful, most honest interpretation. Because a 16-3-5-day period is real, it is measured, it is statistically significant, and it is not explained by random bursting. But what does a 16-3-5-day period actually tell us? The specific natural astrophysical explanations for periodic FRB activity fall into several categories. The most favored involves orbital geometry, a specific binary system in which the FRB source orbits a companion object, and the specific active window corresponds to the specific orbital phase during which the radio beam from the FRB source is directed toward Earth. As the source orbits the companion, the beam sweeps through space, and we detect bursts only when the beam points in our direction. The specific 16-3-5-day period would be the specific orbital period of the binary system. The companion in this model could be a massive star with the FRB source, almost certainly a magnetar, orbiting within the dense stellar wind of its companion. During specific orbital phases, the stellar wind provides more material for the magnetar to interact with, or blocks the signal during other phases, producing the specific active-inactive pattern. The second category involves the specific rotation of the FRB source itself, a precessing neutron star whose magnetic axis wobbles with a specific period, causing the radio beam to sweep past Earth periodically rather than continuously. Neither model is definitively established. Both are consistent with the specific observed period. And the specific discrimination between them requires precisely the kind of detailed observation, timing, polarimetry, spectroscopy across the full period that CHIME and FAST and other instruments are currently conducting. Let me now take you to the specific astrophysical source class that currently provides the most compelling explanation for most fast radio burst magnetars, because understanding what magnetars are illuminates why FRBs are so extraordinary. A neutron star is the collapsed remnant of a massive star that has undergone a supernova explosion. The specific stellar core that survives the explosion is compressed by the explosion's inward propagating shock wave until the specific nuclear density of atomic nuclei is reached throughout the entire object. A neutron star contains approximately 1 to 2 solar masses of matter compressed into a sphere approximately 10 to 20 kilometers across. Its density is comparable to or exceeding atomic nuclear density approximately 1017 kilograms per cubic meter. Neutron stars are also rapidly rotating, inheriting the specific angular momentum of the pre-collapsed stellar core and concentrating it as the star's radius shrinks by a factor of thousands. The fastest rotating neutron stars, millisecond pulsars, complete hundreds of rotations per second. A magnetar is a specific subclass of neutron star with an extraordinarily intense magnetic field of order 10-15 Gauss compared to the 10-12 Gauss of a typical pulsar. This magnetic field is approximately 1 trillion times stronger than Earth's magnetic field and 1,000 times stronger than a typical pulsar's. The specific energy stored in this magnetic field, approximately 1047 joules, is comparable to the total energy released in a supernova explosion. The specific mechanism that allows magnetars to produce fast radio bursts involves the catastrophic release of this magnetic energy. When the magnetar's magnetic field configuration becomes unstable through the specific crust cracking events called starquakes, or through specific reconnection events in the magnetosphere, energy is released impulsively, powering a specific coherent radio emission process that produces the brief, intense burst. The specific confirmation that magnetars can produce fast radio burst-like events came from a galactic source in April 2020. The magnetar SGR 1935 plus 2154, located approximately 30,000 light-years from Earth in the Milky Way, produced a specific burst of radio emission simultaneously with a burst of X-rays. The specific radio burst was detected by CHIME and by the STARE-2 instrument, and its specific properties, millisecond duration, extraordinarily high radioluminosity, simultaneous X-ray emission, were precisely what a magnetar origin FRB model would predict. This was the first direct specific association between a magnetar and FRB-like emission. It did not prove that all FRBs are magnetars. The galactic event was less luminous than the most distant extragalactic FRBs by several orders of magnitude, suggesting either that the most energetic FRBs involve more extreme magnetar events, or that additional source classes exist. But it established that magnetars can produce FRB-like bursts through specific physically understood mechanisms. Let me now tell you about the specific discoveries in the past 2 years that have most significantly advanced understanding of FRBs and that have simultaneously revealed specific new puzzles that existing models do not fully explain. The CHIME telescope in British Columbia has been the specific instrument most responsible for expanding the known FRB population. CHIME is a specific type of radio telescope, a cylindrical reflector array, rather than a traditional dish that observes a large fraction of the sky simultaneously with high sensitivity in the 400 to 800 megahertz frequency range. Its specific design for hydrogen intensity mapping gives it a serendipitous capability for FRB detection, producing the largest and most uniform FRB catalog available. The specific CHIME FRB Catalog 1, published in 2021, contained 536 FRBs detected in the first year of full operations, more than doubling the total number of FRBs known at the time of publication. The specific statistical properties of this catalog, the burst energy distribution, the host galaxy distribution, the spectral properties provided the most comprehensive characterization of the FRB population available. Among the most important specific results from CHIME is the characterization of the FRB energy distribution. The specific rate at which FRBs occur, integrated across the entire observable universe, is estimated at approximately 1,000 per day visible from Earth, representing perhaps 1 billion FRB events per day occurring throughout the universe. This extraordinary rate implies that FRBs are extremely common, that whatever produces them is a frequent and widespread phenomenon in the galaxy population. The specific correlation of FRB rates with galaxy properties, star formation rates, stellar mass, metallicity is a specific active research area. The specific distribution of FRBs among galaxy types, whether they preferentially occur in star-forming galaxies, in passive ellipticals, or without preference, constrains the specific age of the magnetar population responsible. Young magnetars recently formed from massive stellar collapse would preferentially reside in star-forming galaxies. Old magnetars formed long ago from various channels would trace the stellar mass distribution more generally. The specific current data is consistent with a predominantly young magnetar population, but does not exclude contributions from older sources, including compact object mergers and other channels. Let me now take you to the specific new development that has generated the most scientific discussion in the past 2 years, the specific detection of polarization structure in FRB bursts that is providing direct information about the magnetic field environment of the source. Radio waves can be polarized, their electric field vectors can oscillate in a specific plane rather than randomly. The specific polarization properties of radio emission encode information about both the emission mechanism and the propagation environment. For FRBs, which travel billions of light years through magnetized plasma before reaching our telescopes, the specific polarization provides a specific probe of both the source and the intergalactic medium. The specific quantity most directly measurable is the rotation measure, the specific rotation of the polarization angle produced by the magnetic field along the line of sight. In a magnetized plasma, the specific left and right circular polarization components of radio waves travel at slightly different speeds, producing a specific frequency-dependent rotation of the linear polarization angle. The magnitude of this rotation, the rotation measure, depends on the specific integral of the magnetic field times the electron density along the line of sight. For FRB 121102, the prolific repeating source, the specific rotation measure is extraordinarily large and variable. The specific value initially measured at approximately 100,000 radians per square meter is among the largest observed for any extragalactic radio source. And it varies. Different bursts show different rotation measures, varying by tens of thousands of radians per square meter on timescales of weeks to months. This specific variation is extraordinary. A rotation measure of 100,000 radians per square meter implies a specific magnetic field times electron density integral along the line of sight that is orders of magnitude larger than typical intergalactic values. The variation implies that this extreme magnetic environment changes on timescales of weeks, the specific timescale of the source's burst activity. The specific physical environment consistent with these properties is a magnetar embedded in a specific dense magnetized nebula, either the remnant of the specific supernova explosion that created the magnetar, or a specific wind nebula powered by the magnetar's spin-down energy, or a specific active star-forming region with dense magnetized gas. The specific detailed modeling of this environment, connecting the specific rotation measure variations to the specific physical conditions of the source, is an active research area producing new constraints on the magnetar model. Let me now tell you about the specific ongoing puzzle that is most important for understanding why FRBs remain genuinely scientifically mysterious despite the significant recent progress. The specific puzzle involves the diversity of FRB properties, the specific range of burst energies, repetition rates, spectral characteristics, and environmental properties that the growing FRB catalog is revealing. If magnetars are the specific source of all FRBs, we would expect the specific properties of all FRBs to be explicable within a single unified magnetar framework. But the specific observed diversity suggests either a single source class with an extraordinary range of properties, or multiple source classes contributing to the FRB population. The specific most puzzling members of the FRB population are the non-repeating FRB sources for which only a single burst has ever been detected despite specific monitoring. If all FRBs repeat, the non-repeating ones might simply be infrequent repeaters that haven't been observed in the specific active phase. But if some FRBs are genuinely non-repeating, produced by specific catastrophic events, they represent a different population from the repeating sources. The specific discrimination between these possibilities requires specific long-term monitoring of apparently non-repeating FRBs, determining for each source whether the absence of repetition reflects a genuinely non-repeating nature or merely the specific limited monitoring time available. This specific monitoring program is ongoing, and the specific results over the next several years will determine whether the FRB population is unified or diverse. The specific additional puzzle involves the specific FRBs detected from specific galaxy types that magnetar models don't naturally predict. Several FRBs have been localized to specific old passive elliptical galaxies with little ongoing star formation environments where young magnetars should be rare. These sources require either specific alternative formation channels for magnetars in old stellar populations, binary neutron star mergers, accretion-induced collapse of white dwarfs, or genuinely different source classes that produce FRB-like emission through different specific mechanisms. Let me now address something important about the NASA completely baffled framing, because it mixes truth and misleading implication in a specific way that deserves careful examination. NASA is not the primary institution working on FRBs. The specific instruments responsible for most FRB science, CHIME in Canada, PARCS in Australia, FAST in China, the Very Large Array in the United States, are not NASA facilities. The specific scientific agencies primarily involved are the Natural Sciences and Engineering Research Council of Canada, the Commonwealth Scientific and Industrial Research Organization, the Chinese Academy of Sciences, and the National Science Foundation of the United States. NASA has contributed specific relevant observations, particularly through the Swift X-ray Telescope and the Fermi Gamma Ray Space Telescope, which have provided specific multi-wavelength context for FRB events. And the specific NASA Hubble Space Telescope has provided specific optical imaging of FRB host galaxies that constrains the environments of FRB sources. But NASA, completely baffled, misidentifies both the primary scientific community working on FRBs and the specific degree of bafflement that community currently maintains. The accurate version The specific international astrophysical community studying FRBs has developed a specific physically motivated leading explanation magnetars that is supported by specific observational evidence, including the specific detection of FRB-like emission from the galactic magnetar SGR 1935 plus 2,154 inches 2020. The community is not baffled in the sense of having no idea what FRBs are. It is specifically uncertain about the details, whether all FRBs come from magnetars or multiple source classes contribute, what specific mechanism produces the coherent radio emission, whether the diversity of repeating and non-repeating sources reflects a single population or multiple populations. This specific, honest uncertainty is more interesting and more scientifically meaningful than the vague bafflement the headline implies. Let me close this first part with something that honestly captures why FRBs, even without the alien communication framing, deserve the specific excitement and specific attention they are generating in the astrophysical community. Fast radio bursts are extraordinary. They are the most luminous radio transients known, releasing more energy in milliseconds than the sun releases in days. They occur at a rate of approximately 1 billion per day throughout the observable universe, making them one of the most common energetic transient phenomena in the cosmos. They arrive from cosmological distances, probing the specific state of the intergalactic medium across billions of light years of cosmic history. And the specific repeating ones show specific periodicities that provide direct information about the specific orbital and physical properties of their source systems. The specific scientific value of FRBs extends far beyond understanding their specific source mechanism. As cosmological probes, each FRB's specific dispersion measure, the frequency-dependent arrival time delay, is a direct measurement of the specific electron content of the intergalactic medium along the specific line of sight. The specific integral of electron density along billions of light years of cosmic space. By comparing the specific dispersion measures of FRBs at known redshifts to the specific cosmological models, astronomers can constrain the specific baryon content of the universe, the specific fraction of ordinary matter in the intergalactic medium that is otherwise difficult to detect. This specific use of FRBs as baryon probes has already produced the specific result, published in 2020, using a sample of localized FRBs, that approximately half the universe's baryons reside in the specific warm-hot intergalactic medium, resolving the specific missing baryon problem that had puzzled cosmologists for decades. The specific detection and localization of thousands of FRBs by CHIME and its planned upgrades will extend this baryon measurement to specific redshifts and specific lines of sight that will provide the most comprehensive map of the intergalactic medium's specific baryon distribution ever assembled. It's repeating a message, not an alien message. A specific, natural, astrophysical message from magnetars in the centers of distant galaxies, encoded in millisecond radio pulses whose specific properties probe the specific magnetic fields, the specific electron densities, the specific orbital geometries of the most extreme environments in the observable universe. The message is about physics, about the specific state of matter at nuclear density, about the specific configuration of magnetic fields 10 billion times stronger than Earth's, about the specific distribution of ordinary matter through the intergalactic voids that constitute most of the universe's volume. In part 2, I want to go deeper into what the specific periodic repeating FRBs are telling us about the specific binary systems that host them, into what the specific fast telescope's extraordinary sensitivity is revealing about burst substructure that CHIME cannot resolve, and into something that I find genuinely extraordinary, the specific connection between FRB observations and the Hubble tension that we've discussed throughout this series, and how FRBs may provide an independent measurement of the cosmic expansion rate that could help resolve the most important outstanding problem in cosmology. It's repeating a message. And when you understand what the message actually says, in the specific language of astrophysics rather than the specific language of science fiction, it is more interesting, more precise, and more consequential than any alien communication could be. So we'd arrived at this place where fast radio bursts, millisecond duration flashes of radio emission of extraordinary luminosity arriving from cosmological distances are genuinely one of the most scientifically interesting and most actively investigated phenomena in contemporary astrophysics. Not because of alien communication, but because of the specific, real, astrophysically grounded properties that make them both extraordinarily energetic and extraordinarily informative. The leading explanation magnetars, extraordinarily magnetized neutron stars releasing specific bursts of energy through starquake events and magnetic reconnection, is supported by specific observational evidence, including the 2020 detection of FRB-like emission from the galactic magnetar SGR 1935 plus 2154. The specific repeating sources, particularly FRB 201809116b with its 1635 day period, and FRB 201211002a with its extraordinary rotation measure variability, are providing specific detailed information about the source environments and orbital configurations that no other astrophysical probe can access. Now I want to go deeper into what the FAST telescope's extraordinary sensitivity is revealing about burst substructure that previous instruments couldn't resolve, into the specific connection between FRB observations and the Hubble tension, and into the specific recent discoveries that are most challenging to the magnetar model and most suggestive of either additional source classes or additional physical processes. Let me start with FAST, because this specific instrument has transformed what is knowable about FRB burst properties. The 500-meter aperture spherical telescope FAST, located in a natural depression in Guizhou province in southern China, is the most sensitive single-dish radio telescope ever built. Its specific collecting area, a reflective surface covering 500 meters in diameter, or about 30 football fields, gives it a sensitivity approximately 5 times greater than the previous record holder, the Arecibo telescope, which collapsed in December 2020. For FRB science, FAST's specific sensitivity advantage translates directly into the ability to detect the faintest bursts from known repeating sources and to resolve the specific temporal and spectral structure of bursts with a precision that no previous telescope could approach. The specific observations of FRB 201211002a and other repeating sources by FAST have revealed sub-millisecond structure within individual bursts, specific microbursts, spectral drifts, and temporal modulations that encode direct information about the specific emission mechanism and the specific physical scale of the emitting region. The specific FAST observations of FRB 20201124a, a repeating FRB discovered in 2020 and localized to a specific spiral galaxy at a redshift of approximately 0.098, have been particularly revealing. In a specific observing campaign in 2021, the FAST team detected more than 1,600 individual bursts from this source in 47 days of monitoring, the largest sample of bursts ever detected from a single FRB source in such a short time. The specific statistical analysis of these 1,600 bursts revealed a specific, striking pattern. The burst energies followed a specific power law distribution, the same specific mathematical form that describes earthquake energy distributions, avalanche sizes, and other natural phenomena characterized by specific scale-free dynamics. The specific power law exponent, the specific slope of the energy distribution match predictions from a specific class of models called self-organized criticality, in which the system naturally evolves toward a specific critical state from which energy is released in bursts of all sizes following a specific power law. This specific statistical signature power law energy distribution with a specific exponent is a specific prediction of the magnetar starquake model. In this model, the magnetar's crust accumulates specific stress from the ongoing evolution of the magnetic field, releasing this stress in specific starquake events of all sizes following the specific power law distribution. The fast observation of this specific distribution in FRB 20201124A provides a specific quantitative confirmation of the starquake mechanism. But the fast observations of FRB 20201124A also revealed something specific and unexpected, a specific secular variation in the polarization properties of the bursts over the 7-day observing campaign. The specific rotation measure, the measure of magnetic field along the line of sight, showed specific irregular variations, sometimes changing by thousands of radians per square meter between consecutive observing sessions. The specific timescale and magnitude of these rotation measure variations are not easily explained by the standard magnetar in nebula model. The specific changes require either a specific, highly magnetized, dynamically variable medium surrounding the source, something like a companion star's magnetized stellar wind, variable on the orbital timescale, or specific changes in the magnetosphere of the magnetar itself. This specific observation has motivated a specific new class of models, magnetar binary systems, in which the FRB source is a magnetar in a specific binary orbit with a massive stellar companion, and the rotation measure variations reflect the specific changing line of sight through the companion stellar wind as the orbital phase changes. Let me now tell you about the specific connection between FRB observations and the Hubble tension, because this connection is one of the most scientifically exciting and most specifically underappreciated aspects of FRB science. The Hubble tension, the specific 5 sigma discrepancy between the Hubble constant measured from the CMB by Planck and the Hubble constant measured from the local distance ladder by Cepheid variables and supernovae, is the most significant, outstanding problem in cosmology, as we established in the JWST conversation. Any independent measurement of the Hubble constant, particularly one using a completely different physical phenomenon and a completely different measurement chain, is extraordinarily valuable for understanding whether the tension reflects new physics or systematic errors in the existing measurements. Fast radio bursts provide a specific independent method for measuring the Hubble constant using the specific relationship between FRB dispersion measures and redshifts to constrain the specific baryon content of the intergalactic medium and thereby the specific expansion history of the universe. The specific method works as follows. A fast radio burst dispersion measure the frequency-dependent arrival time delay is proportional to the specific integral of the electron density along the line of sight from the source to the telescope. In the intergalactic medium, the specific electron density is determined by the specific baryon density and the specific ionization fraction, both of which depend on the specific cosmological parameters, including the Hubble constant. For a sample of FRBs with specific well-measured redshifts and specific well-measured dispersion measures, the specific relationship between the two encodes information about the specific cosmological parameters. Different values of the Hubble constant and different specific baryon densities predict different specific relationships between dispersion measure and redshift. By measuring this relationship from a large sample of localized FRBs, the Hubble constant can be constrained independently of both the CMB and the local distance ladder. The specific current FRB-based Hubble constant measurement published in 2022 using a sample of approximately a dozen localized FRBs gives H0 equals 73 plus or minus 12 km divided by S divided by MPC. The specific uncertainty is large. The 12 km S MPC error bar reflects both the small sample size and the specific uncertainty in the intergalactic medium's baryon distribution. But the specific central value is consistent with the local distance ladder measurement rather than the CMB Planck measurement, a specific, intriguing result that will become more precise as the localized FRB sample grows. The planned square kilometer array, whose early science operations began in 2024 and whose full operations will reach nominal sensitivity by the early 2030s, will detect FRBs at rates of thousands per year and localize hundreds to thousands of them annually. The specific Hubble constant measurement from thousands of localized SCFRBs will have a specific precision of approximately 0.5 kilometers SPT, sufficient to definitively resolve the Hubble tension at the specific level of the current 5 sigma discrepancy. If the FRB-based Hubble constant measurement with SKA precision confirms the local distance ladder value 73 kilometers SPC rather than Planck's 67 kilometers SPC, the specific implication is that new physics beyond lambda CDM is required, since the specific CMB measurement would then be inconsistent with both independent local measurements. If the FRB measurement confirms the CMB value, systematic errors in the local distance ladder become the specific explanation. And if the FRB measurement gives an intermediate value, specific new possibilities, evolving dark energy, specific inhomogeneous matter distribution become more motivated. Let me now take you to the specific recent discoveries that are most challenging for the magnetar model, because honest science requires presenting not just the supporting evidence, but the specific tensions. The specific most challenging discovery for the magnetar model involves FRBs detected in specific environments where young magnetars should not exist. The specific most striking example is FRB 202000120E, a repeating FRB localized not to a distant galaxy but to a specific globular cluster associated with the galaxy M81, approximately 11.7 million light-years away. Globular clusters are specific, ancient, stellar populations, gravitationally bound collections of hundreds of thousands to millions of stars formed 10 to 13 billion years ago, containing no ongoing star formation and no young massive stars. Young magnetars formed from the collapse of massive stars and supernova explosions should not exist in globular clusters because the massive stars that produced them died billions of years ago. FRB 202000120E is repeating. It is in a globular cluster. It is an FRB. The specific challenge this poses for the magnetar model requires either a specific alternative magnetar formation channel in old stellar environments, compact object mergers, accretion-induced collapse of white dwarfs, or a specific alternative FRB source that is not a magnetar. The specific compact object merger channel is physically motivated. In globular clusters, the specific high stellar density creates specific dynamical conditions where neutron stars can be brought into specific tight binaries through gravitational capture, and where neutron star mergers, neutron star white dwarf mergers, and white dwarf mergers occur at specific enhanced rates compared to the field galaxy population. Specific neutron star mergers can produce specific rapidly rotating, highly magnetized neutron stars born spinning faster and with stronger fields than typical core collapse magnetars that might produce FRBs through specific emission mechanisms different from the starquake model. The specific accretion-induced collapse channel is also physically motivated in globular clusters. Specific white dwarfs in specific binary systems can accrete mass from specific companion stars until they reach the Chandrasekhar limit and collapse to form neutron stars rather than thermonuclear supernovae producing specific young, highly magnetized neutron stars in old stellar environments. Both channels are physically possible. Neither is directly confirmed for FRB 202000120E. The specific discrimination between them requires specific multi-wavelength observations that are ongoing. The specific implication of FRB 202000120E for the FRB population is important. If some FRBs come from magnetars formed through specific old population channels rather than exclusively from young magnetars in star-forming environments, the specific FRB population is more diverse than the simplest unified model implies, and the specific host galaxy distribution of the FRB population reflects a specific mixture of young and old source populations. Let me now tell you about the specific theoretical frontier in FRB physics, the specific question of the emission mechanism, because this is the specific aspect of the FRB problem that remains most genuinely uncertain. We know with specific confidence that FRBs are coherent radio emission. The specific extraordinarily high brightness temperatures of FRB bursts, the specific temperature a blackbody source would need to produce the observed specific radio brightness are of order 1035 Kelvin. No thermal source can reach this temperature. The specific emission must be coherent, produced by specific in-phase motions of large numbers of charged particles whose radiation adds constructively rather than independently. Coherent radio emission is produced by several specific mechanisms in known astrophysical sources. Pulsars rotating neutron stars produce specific coherent radio emission through mechanisms involving specific plasma instabilities in the pulsar magnetosphere. Solar radio bursts produce coherent emission through specific plasma emission mechanisms. The specific emission mechanism responsible for FRBs is the specific open question. The specific leading models for FRB coherent emission include synchrotron maser emission, a specific mechanism in which relativistic electrons moving in a specific magnetic field produce coherent emission at specific frequencies, through a specific maser-like amplification process and curvature radiation from specific charge bunches, a specific mechanism in which specific groups of charged particles moving along specific curved magnetic field lines produce coherent emission through the specific interference of their radiation. The specific discrimination between these emission mechanisms requires specific observational signatures, particular spectral shapes, particular polarization properties, particular temporal structures that the growing high-quality data sets from FAST and CHIME are beginning to constrain. The specific sub-millisecond structure revealed by FAST, the particular microburst morphologies and spectral drift patterns provide specific constraints that rule out some emission models and favor others. The specific current state of the emission mechanism question is synchrotron maser emission from specific shock fronts in magnetar winds is the specific best constrained model consistent with the specific energy scales, spectral properties, and temporal structures observed. But curvature radiation from specific charge bunches in the magnetar magnetosphere remains specifically viable, and the two models may both contribute to different specific burst classes. This genuine, specific uncertainty about the emission mechanism is one of the specific reasons that NASA, completely baffled, is closer to the truth than the typical science communication presents. Not because the source class is mysterious, but because the specific physics of how magnetars produce coherent radio bursts of the observed specific luminosity remains genuinely incompletely understood. Let me now tell you about a specific recent development that has dramatically changed the specific observational landscape for FRBs, the specific real-time localization capability that new instruments are providing. Until recently, the specific challenge of FRB science was that most detections provided only approximate sky positions good enough to identify the specific host galaxy for the nearest and brightest events, but insufficient for the specific precise localization needed for detailed host galaxy characterization. The specific new instrument that has transformed this situation is the Deep Synoptic Array DSA at the Owens Valley Radio Observatory in California. The DSA is a specific array of individual radio antennas that operates as a specific interferometer, providing specific arc-second precision localizations for every FRB it detects in real time. The specific scientific significance of real-time arc-second localization is immediate and profound. With a specific precise position available within seconds of the burst, telescopes across the electromagnetic spectrum can be pointed at the specific location before any afterglow or counterpart emission fades. X-ray, optical, infrared, and gamma-ray telescopes can observe the FRB location during and immediately after the burst, searching for specific multi-wavelength counterparts that would constrain the emission mechanism, the source environment, and the progenitor system. The specific first multi-wavelength counterpart campaign enabled by the DSA's real-time localization occurred in 2023, targeting a specific repeating FRB localized to a specific edge-on spiral galaxy at a moderate redshift. The specific multi-wavelength observations coordinated across the Swift X-ray telescope, the Very Large Telescope, and optical, and several radio arrays provided the most comprehensive multi-wavelength dataset ever assembled for a repeating FRB source. The specific results are being analyzed and are expected to produce specific constraints on the source environment and emission mechanism that no previous FRB observation has achieved. The planned full DSA deployment DSA 2000, a specific 2,000 antenna array planned for completion in the late 2020s, will localize thousands of FRBs annually with specific arc-second precision, enabling specific comprehensive multi-wavelength follow-up programs that will transform the specific observational characterization of the FRB population. Let me close this second part with something that connects the FRB story to the broader arc of what this series has been building, because FRBs are not an isolated phenomenon, but a specific new window on the universe that connects to many of the themes we've been exploring. Throughout this series, we've been building a picture of a universe that is revealed through specific windows, electromagnetic radiation at specific wavelengths, gravitational waves, cosmic rays, neutrinos. Each window reveals a different aspect of the same physical reality. The gravitational wave background reveals the history of galaxy mergers. The CMB reveals the structure of the early universe. The deep ocean reveals the extent of the biosphere, and FRBs are a specific new window revealing the specific state of the intergalactic medium, the specific properties of the most extreme compact objects, and potentially the specific expansion history of the universe through the Hubble tension. The specific scientific value of FRBs is not just understanding what produces them, it is using them as specific cosmological probes, the specific flashlights illuminating the specific dark material between galaxies that no other probe can access with comparable efficiency. The specific dispersion measures encode the specific baryon distribution. The specific rotation measures encode the specific magnetic field distribution. The specific arrival time structure encodes the specific turbulence of the intergalactic medium. And the specific localization to specific host galaxies encodes the specific star formation, history, and stellar population of the regions that produce them. It's repeating a message. The message is specific and scientifically rich. It says, the universe between galaxies is filled with specific ionized gas whose specific density and specific magnetic field are being mapped one burst at a time by the specific millisecond radio pulses of distant magnetars. The specific intergalactic medium, the specific warm-hot plasma that constitutes the missing baryons, that connects galaxies through specific cosmic filaments, that carries specific magnetic fields frozen in from the specific epoch of reionization, is being illuminated by these specific cosmic flashlights in a way that no other astronomical probe can match. In part 3, I want to bring everything together into the complete picture of what FRBs mean for the future of multi-messenger astronomy, for the specific question of what they might eventually tell us about the initial conditions of the universe, and for what I think is the most profound implication of the entire FRB story. Not that we found alien messages, that we found a specific new way to read the universe's oldest and most inaccessible records, the specific state of the intergalactic medium written in the dispersion of radio pulses from the universe's most extreme objects. It's repeating a message. And the specific message, when translated from the language of radio dispersion and rotation measures into the language of cosmology and astrophysics, is one of the most information-rich signals the universe has ever provided. So we'd arrived at this place where fast radio bursts, far from being alien messages, are specific, natural, astrophysically grounded phenomena whose scientific value extends far beyond understanding their own origin. The magnetar model is supported by specific evidence, including the 2020 galactic detection from SGR 1935 plus 2154. The FAST telescope has revealed specific burst substructure constraining emission mechanisms. The specific 16-3-5-day period of FRB 201-809-16b points toward binary orbital geometry. FRB 2020-1124A's specific rotation measure variability suggests a dynamically changing magnetized environment. FRB 2020-0120E's location in a globular cluster challenges the simple Young magnetar model and requires specific alternative formation channels. And the specific dispersion measure redshift relationship encodes a specific independent measurement of the Hubble constant that thousands of localized SKA FRBs will constrain to 0.5 kilometers SMPC, precision sufficient to definitively resolve the most important outstanding problem in cosmology. Now, I want to bring it all the way home into what FRBs mean for the future of multi-messenger astronomy, into the specific connection between FRB science and the deepest questions about the universe's large-scale structure, and into what I think is the most profound implication of the entire FRB story, what it means that the universe is continuously broadcasting through specific millisecond radio pulses from its most extreme objects a specific record of its own structure and history that no other observational program can read with comparable efficiency. Let me start with the future. The specific trajectory of FRB science over the next decade is toward what astronomers call the precision era, the specific transition from discovering and characterizing the FRB phenomenon to using it as a precision cosmological tool with specific quantitative constraints on fundamental parameters. The specific instrument that will drive this transition most powerfully is the Square Kilometer Array. The SKA is not a single telescope, but a specific distributed network of thousands of individual antennas across South Africa and Australia, connected electronically to function as a single aperture with a total collecting area of approximately 1 square kilometer. The specific sensitivity improvement over current instruments, approximately 50 times more sensitive than any existing radio facility, translates directly into both the rate of FRB detection and the precision of each detected bursts characterization. The The specific SKA FRB science program is expected to detect FRBs at rates of several thousand per year with specific arc-second precision localizations for a substantial fraction of them. Over a 10-year survey, the SKA will accumulate a catalog of tens of thousands of localized FRBs, a specific sample large enough to use the dispersion measure redshift relationship as a precision cosmological tool with uncertainties comparable to the Planck CMB measurements and the supernovae distance ladder. But the SKA's contribution to FRB science extends beyond the specific Hubble constant measurement. The specific magnetic field maps encoded in FRB rotation measures, accumulated over thousands of lines of sight through the intergalactic medium, will provide the first comprehensive three-dimensional map of the specific magnetic field structure of the cosmic web. This specific map will constrain the specific origin of intergalactic magnetic fields, whether they were generated during the specific epoch of reionization, during specific galaxy formation processes, or during the specific primordial epoch of the early universe. The specific magnetogenesis question, how the universe acquired its specific large-scale magnetic fields, is one of the specific open questions in cosmology that FRBs are uniquely positioned to address. Primordial magnetic fields generated during inflation or during specific phase transitions in the early universe would have specific statistical properties in the FRB rotation measure distribution that field generated during reionization would not. The specific statistical analysis of thousands of rotation measures across the sky will directly constrain these specific primordial scenarios. Let me tell you about the specific multi-messenger program that FRBs are enabling and why this specific program represents one of the most important scientific developments of the next decade. Multi-messenger astronomy, the specific coordinated observation of the same event in multiple physical channels, has produced some of the most important results in recent astrophysics. The specific gravitational wave detection of the neutron-star merger, GW 170817 in 2017, simultaneously observed in gravitational waves by LIGO and Virgo, and in electromagnetic radiation across every wavelength from gamma rays to radio waves, was the specific event that demonstrated the power of the multi-messenger approach. It confirmed that neutron-star mergers produce short gamma ray bursts. It confirmed that neutron-star mergers produce the specific heavy elements, gold, platinum, uranium, that our process nucleosynthesis requires. It provided the first specific standard siren measurement of the Hubble constant from gravitational wave observations. FRBs are the specific next major target of the multi-messenger approach. The specific real-time localization capabilities of the DSA, CHIME, and their successors combined with the specific coordination infrastructure of the astronomer's telegram and specific automated target of opportunity systems are enabling the specific search for multi-wavelength counterparts to FRB events in real time. The specific scientific goals of FRB multi-messenger programs are concrete and achievable. If FRBs are magnetars, specific magnetar-producing events, specifically certain supernovae, specific compact object mergers, should produce specific FRBs that are simultaneously observable in gravitational waves by LIGO and Virgo for nearby sources, in neutrinos by IceCube and Hyperkamiokande, and in gamma rays by the Fermi Gamma Ray Space Telescope. The specific detection of a gravitational wave signal simultaneously with an FRB would provide the most direct possible confirmation of the specific compact object origin of the FRB source. The specific properties of the gravitational wave signal, the specific chirp mass, the specific merger time, the specific sky position, would directly determine the specific nature of the merging objects and provide a specific test of the compact object merger formation channel for old population FRBs, like FRB. 2.0.2.0.0.1.2.0.e. The specific neutrino detection of an FRB source would provide direct information about the specific particle acceleration processes in the magnetar environment, constraining whether the specific burst emission involves specific hadronic processes or is purely electromagnetic. None of these specific coincident detections has yet been made. The specific rate of FRBs, close enough for gravitational wave detection within approximately 100 MPC, is too low for current instruments. But the specific planned sensitivity improvements to both the FRB detection infrastructure and the gravitational wave detectors, particularly the planned A+ and Voyager upgrades to LIGO, will extend the specific horizon coincident detection to distances where the specific event rate makes detection probable within the next decade. Let me now tell you about something that connects the FRB story to the specific deepest questions about the structure of the universe, the specific connection between FRB observations and the mapping of the cosmic web. The cosmic web, the specific large-scale structure of the universe, consisting of specific filaments of galaxies and matter, connected at specific nodes containing galaxy clusters, separated by specific voids that contain little matter, is the specific largest structure in the observable universe. It is the specific direct consequence of the specific primordial density fluctuations that inflation generated, the specific pattern that grew under gravity from the specific initial conditions of the Big Bang into the specific network of structure we observe today. Mapping the cosmic web requires specific probes of the specific matter distribution on the specific scales of tens to hundreds of megaparsecs. Current electromagnetic observations, galaxy redshift surveys, weak gravitational lensing, the Lyman alpha forest, provide specific partial maps of the cosmic web's specific luminous and dark matter components. But the specific warm, hot, intergalactic medium, the specific diffuse plasma that fills the specific filaments of the cosmic web, constituting approximately 40 to 50% of all ordinary matter in the universe, is extraordinarily difficult to observe directly. It is too hot for specific neutral hydrogen observations, too cool for specific X-ray observations, too diffuse for specific optical or infrared detection. FRBs probe this specific warm-hot intergalactic medium directly. Each specific FRB line of sight through the specific cosmic filaments produces a specific dispersion measure contribution from the specific warm-hot plasma in those filaments. By comparing the specific dispersion measures of FRBs at specific sky positions with the specific galaxy distribution at those positions using the specific galaxy surveys like DESI and Euclid to map the large-scale structure, astronomers can specifically reconstruct the specific three-dimensional distribution of the warm-hot intergalactic medium with a completeness that no other probe approaches. The specific scientific program correlating FRB dispersion measures with specific large-scale structure maps has already produced the first specific detections of cosmic web filaments in FRB data. The specific 2021 paper by Connor and Ravi demonstrated the specific statistical detection of excess FRB dispersion measure towards specific galaxy filaments, the first specific direct detection of the warm-hot intergalactic medium in specific cosmic filaments through FRB observations. With the specific thousands of localized FRBs that the SKA will provide, this specific program will produce the most comprehensive three-dimensional map of the universe's ordinary matter distribution ever assembled, a specific reconstruction of the cosmic web's specific baryonic content that will complement the specific dark matter maps from weak gravitational lensing surveys and the specific galaxy distribution maps from spectroscopic surveys into a complete, specific, multi-component picture of the large-scale structure. Let me now address the specific question that I think deserves the most honest treatment, the specific question of whether FRBs could ever be used to search for technosignatures and why the current evidence provides no support for this. The search for extraterrestrial intelligence SETI uses specific criteria for distinguishing specific natural astrophysical signals from specific artificial signals. The specific criteria include signals that cannot be explained by known natural processes, signals with specific artificial structure like prime number sequences or mathematical constants, signals originating from specific locations consistent with planetary systems rather than extreme astrophysical environments, and signals with specific properties inconsistent with known emission mechanisms. FRBs fail every specific one of these criteria as candidates for artificial signals. They are explained, at least in broad outline, by specific, physically motivated natural processes involving magnetars. Their specific temporal and spectral structure is consistent with specific plasma emission processes in magnetospheric environments, not with specific modulation by intelligent transmitters. They originate from specific galactic environments, massive star-forming regions, compact object neighborhoods inconsistent with the specific orbital environments of planetary systems. And their specific properties, particularly the extraordinarily high brightness temperatures and specific spectral structures, are specifically characteristic of coherent plasma emission rather than of specific artificial modulation. None of this constitutes a proof that no FRB has an artificial component. The universe is under no obligation to make SETI easy. But the specific current evidence provides no positive support for the artificial hypothesis, and the specific natural magnetar hypothesis provides specific, quantitative, observationally supported explanations for all the specific observed properties. The specific, honest position is FRBs are almost certainly natural phenomena. The specific evidence for this is positive and specific. The specific evidence for any artificial component is absent, and the specific scientific resources of the FRB community are appropriately focused on the specific natural explanations that the evidence supports, not on the specific artificial hypotheses that the evidence does not. This is what honest science looks like in the face of extraordinary phenomena. Not immediately attributing the extraordinary to the exotic, not jumping from millisecond radio pulses of extraordinary luminosity from cosmological distances to alien transmissions, but following the specific evidence where it leads towards specific natural explanations that are themselves extraordinary, that reveal specific new aspects of the universe's most extreme objects, and that provide specific new tools for cosmological measurement that would be scientifically valuable regardless of their specific astrophysical origin. Let me now bring together the complete picture of what FRBs are, what they have revealed, and what they will reveal in the coming decade. Fast radio bursts are specific millisecond duration radio transients of extraordinary luminosity, releasing more energy in radio waves in milliseconds than the sun releases in days originating from cosmological distances, detected at a rate of hundreds per year by CHIME and expected at rates of thousands per year by the SKA. Their leading explanation magnetars, extraordinarily magnetized neutron stars releasing specific bursts of magnetic energy, is supported by specific observational evidence, including the galactic detection from SGR 1935 plus 2154. The specific power law burst energy distributions consistent with starquake models, and the specific rotation measure signatures consistent with magnetized nebular environments. The specific repeating FRBs, particularly the 16, 3, 5-day periodic FRB 201809116B and the prolific FRB 202011224A are providing specific detailed information about the specific binary systems and specific magnetospheric environments of their sources that no other astrophysical probe can access. The specific connection to the Hubble tension through the specific dispersion measure redshift relationship positions, FRBs, as the specific independent cosmological tool that will either confirm or refute the most significant, outstanding discrepancy in modern cosmology with the specific SKA precision measurements of the late 2020s and 2030s, and the specific connection to the cosmic web through the specific correlation of FRB dispersion measures and rotation measures with the specific large-scale structure of the universe will produce the most comprehensive three-dimensional map of the universe's ordinary matter distribution ever assembled, resolving the specific missing baryon problem and constraining the specific magnetogenesis of intergalactic magnetic fields. Let me close with the most important and most personally significant thing that the FRB story tells us, not about the specific astrophysics of magnetars or the specific cosmology of the Hubble tension, but about what it means to live at the specific moment in the history of astronomy when this phenomenon was discovered and is being understood. For most of human history, the radio universe was invisible to us. Not because it wasn't broadcasting. It has been broadcasting since the first stars formed, since the first neutron stars were created in the first supernovae, since the first magnetars accumulated the specific, extraordinarily intense magnetic fields that allow them to release bursts of energy powerful enough to be detected across billions of light years. It was broadcasting. We simply didn't have the specific technology to hear it. The specific instruments that changed this Jansky's antenna in 1932, the specific development of radio telescope technology through the mid-20th century, the specific development of digital backends that allow coherent detection of millisecond transients, the specific development of the chime cylinder array and the fast dish are the specific products of specific human engineering effort built to answer specific scientific questions, producing specific serendipitous discoveries that the builders didn't anticipate. The Lorimer burst, found in 2007 inches, 2001 archival data, 6 years of a specific signal sitting unexamined in specific data files, waiting for the specific moment when the specific question, what is this, was asked by a specific person looking at it. Duncan Lorimer and David Narkovich asking that specific question, finding the specific burst, publishing the specific paper, opening the specific window. Since that specific moment, a specific community of hundreds of radio astronomers across a dozen countries has been examining this specific window with increasing sophistication, building specific instruments, developing specific algorithms, making specific theoretical proposals, designing specific multi-wavelength follow-up programs. The specific chime catalog, the specific fast burst storms, the specific DSA localizations, the specific SKA plans, all of these are the specific products of this specific community's specific collective effort. It's repeating a message. The message is not from aliens. The message is from the universe itself, from the specific physical processes that operate in the most extreme environments accessible to observation, encoded in specific millisecond pulses of coherent radio emission that have been traveling for billions of years through the specific intergalactic medium before arriving at specific radio telescopes on a specific planet orbiting a specific unremarkable star in a specific spiral galaxy. The specific content of the message is precise and rich. It says the intergalactic medium has a specific baryon content that encodes the specific expansion history of the universe. The specific magnetic fields, threading the cosmic web, have a specific origin in the specific processes of the early universe and galaxy formation. The specific magnetars that produce the bursts have specific properties, specific magnetic field strengths, specific burst energetics, specific emission mechanisms that encode specific physics of matter at nuclear density in extraordinarily strong magnetic fields. And perhaps most importantly, the specific Hubble constant encoded in the specific dispersion measure redshift relationship of thousands of localized FRBs will tell us with specific precision whether the most significant outstanding discrepancy in modern cosmology reflects new fundamental physics or systematic errors in one of the measurement chains that revealed it. This specific question, whose answer will determine whether lambda CDM requires fundamental modification or whether the tension is an artifact, will be answered by a specific astronomical instrument that nobody anticipated would provide this answer when it was designed. CHIME was built to map the distribution of neutral hydrogen for cosmological studies. It found FRBs serendipitously. The specific FRB cosmology program, using these specific serendipitous detections to constrain the Hubble constant, was not in the original science case. This is how astronomy makes its most important discoveries. Not always by looking where the models say to look, by building sensitive instruments, pointing them at the sky, and being surprised by what the universe is actually doing. The universe has been broadcasting fast radio bursts for billions of years. We have been listening with the specific instruments capable of hearing them for less than 20. In that 20 years, we have gone from a single archival burst found by accident to a specific community with specific dedicated instruments detecting hundreds per year, localizing dozens per host galaxy, mapping the specific intergalactic medium with unprecedented specificity, and planning the specific instruments that will use these specific cosmic flashlights to measure the specific expansion rate of the universe with precision sufficient to resolve the specific most important problem in modern cosmology. This is the specific extraordinary thing that the FRB story tells us. Not that aliens are broadcasting, that the universe is broadcasting constantly from its most extreme objects through the specific medium of millisecond radio pulses, and that we have, in the specific past 20 years, developed the specific technology to hear what it is saying. It's repeating a message. The message is about the universe itself, about its specific baryon distribution, about its specific magnetic field structure, about its specific expansion history, about the specific physics of matter at the most extreme densities accessible to observation, and about the specific Hubble constant, the specific rate at which the universe is expanding, that the specific thousands of localized FRBs from the specific SKA will measure with a specific precision that will either confirm, fundamentally revise the specific standard model of cosmology that a century of astronomy has assembled. The universe has been patient. It has been broadcasting for billions of years. We are finally listening carefully enough to hear what it is saying. And what it is saying in the specific language of radio dispersion and rotation measure and burst energy distribution and periodic repetition is more informative, more precise, and more scientifically consequential than any message from any intelligence we might imagine. It is a message about what the universe is. And we are right now in the specific process of learning to read it.